lagging insulation. So the materials most suitable for application to storage tank are in the form of blankets or molded sections. Glass silk blanket of 85% magnesia or slag wool. So when applied, this material should provide a lagging efficiency of approximately 75%. Lagging efficiency is also insulation efficiency. All lagging should be reinforced with wire netting, panikumalas, either incorporated into the blanket or secured to anchor points on the tank surface. A weatherproof surface finish should finally be applied to the lagging. Okay. Pipework system. So sa pipework system, unahin natin yung handling temperature kasi kailangan siya mag-flow. So oil pipeline system transfer oil from storage to the oil burner at specified conditions of pure pressure, viscosity, temperature, and rate of flow. Itong tatlong to. Apat. Pressure, viscosity, temperature, and rate of flow. So there can be considerable variety in the choice of system, but each design, particularly correct pipe sizing and temperature control, is most important if it is to function properly. System, yung mga diagrams. So distillate grades are usually handled at ambient temperature, provided these are not below the cloud point when using gas oil. So residual grades, on the other hand, are handled at temperatures above ambient kasi mas high ang viscosity nito. So the recommendation of table 1 should always be followed regarding minimum recommended handling temperature. So ito yung mga recommendations. Light fuel oil, medium fuel oil, heavy fuel oil. Yeah. Minimum storage, 10C, 25C, 35C. Minimum temperature at outflow, yung sa supply, paglabas niya, 10C, 30C, 45C. Next, handling equipment. 2 items of equipment should always be inserted into the handling system as close to the storage tank as possible. These are the filter and the fire valve. So filters to prevent foreign matter from damaging component and choking valves or atomizer or pieces. Filters must be incorporated into the handling system near the tank. Fire valve, a valve that closes in case of fire, should be inserted in the oil fuel line to the oil burning equipment and fitted as close to the tank as possible. Yeah. This is fire protection. Types of system. So dalawa, meron tayong gravity and the ring main system. So gravity system in general will handle distillate gains at ambient temperatures and residual oils at pumping or atomizing temperature. Kasi yung sa burner, may mga tawag doon atomizing temperature, di ba? Okay. Lagging and tracing, insulation and heat tracing will be required with residual grades to prevent cooling of the oil to below handling temperature. I-maintain niya kahit sa piping. Ang lagging doon sa tanke, lapse tracing doon sa pipe. Mabalutan mo siya ng steam trace or electric tape na umiinit. Okay. Ring main system. Ang ring main system draws oil from storage and circulates it to consuming point in turn. The balance of the oil being returned either to the suction side of the circulating pump or to storage. CBC type of gravity system. So one is the gravity system. A gravity system is one in which the oil flows directly from the storage or service tank through the gravity feed line. So walang pump. Dito namang pump-assisted gravity. A pump-assisted gravity system is one in which oil flows by gravity from storage. Sa baba niya, ano na yun? Pump. Booster niya. Okay? So, abot. Kasi may required pressure kasi doon sa burner. So gravity system. So gravity system is one in which a pump associated with the oil burning equipment is used to suck the oil pump at the tank in which the level of the oil can be below the level of the pump, so underground. Yeah. 3 types of ring main system. Meron tayo hot oil system. This is the most important of the three types since it offers economies of installation and running costs. Diba? Maliit yung pipe mo. The smallest pipe sizes and fittings can be used with low viscosity, high temperature oil. Take note, pag mataas ang temperature, mababa viscosity. And the number of line heaters is minimized. Karami. Kasi dito, isa lang ang temperature required mo. So, atomizing. So, isang heater lang. So, the oil is circulated at atomizing temperatures, and in consequence, the system is less liable to be affected by pressure fluctuation due to variation in viscosity or small changes in viscosity of the oil as delivered. The system should usually be considered as the first possibility and only discarded in favor of warm or cold oil system, the other two types, where this will give some real advantage. So yan. Ito yung ring. Isang heater lang, dalawa kasi parallel siya. Isang inertan lang, tapos loop na dito. Pare-paras kasi ang ano yan, temperature. Atomizing. And next, the warm oil ring mains. This system is similar to cold oil ring main, but includes provision for heaters in the circuit to maintain oil temperature between minimum handling and atomizing level between. This provides a reduction in oil viscosity and reduces pipe friction. The circulation temperature of the oil should be chosen to give the minimum pressure drop. Ito ang point dito. Consistent with the system design when circulating 1.5 to 3 times the maximum takeoff and using a suitable pipe diameter. The circulation temperature should allow a reasonable margin below the specified atomizing temperature to facilitate the selection of the necessary line heaters for branch line between the ring main and oil-bearing main. 3. The cold oil ring mains. This system is mainly used where different atomizing temperatures are required at various consuming points where a branch line would be unacceptably long. Yan. Sabihin, doon na sa ang heater niya, doon na sa individual. Diba? So the system should only be used where the length of pipeline involved and the quantity of oil circulated will not cause an excessive pressure drop due to friction. Pipe sizing. So factors must be taken into account when assessing pressure drop, pipeline viscosity, flow conditions, flow rate, and the length of pipeline. So paglabas niyan is layout. So viscosity. So pressure drop is directly proportional to viscosity. The effect of heat loss from pipelines and consequent increase in viscosity should also be considered. So ito yung mga properties, viscosity properties at temperatures in terms of SSU, so yung type of liquid oil, yan, fuel and diesel oil. So ito naman yung mga viscosity conversion. In terms of SSU, makuha mo ito yung kinematic viscosity and Cinti stock. Yan, Seibert second rule. So, ibang units yan. So, yan. So, conversion, pwede kang gumamit ng sa table. So, ito. Approximate. Pwede ka interpolate. So, to convert viscosity equation is ito. Kinematic viscosity B is absolute viscosity mu over density rho. Itong B, like symbol, ang tawag yan is mu and U. So 1 stock is 1 centimeter squared per second or 100 centistock. And 1 poise is 1 gram per centimeter second or 100 centipoise. Then the kinematic viscosity in centistock is equal to absolute viscosity in centipoise divided by just the specific gravity. Okay. So from the table or given problem na SSU, ito yung conversion mo. Centistock is equal to 0.226 times SSU minus 105 over SSU, where SSU is from 32 to 100, including 32 and 100. So this is now, or 0.22 times SSU times minus 135 over SSU, or SSU greater than 100. Hindi kasama yung 100. To convert viscosity from SSF to centistock, ito naman, centistock is equal to 2.24 times SSF minus 184 over SSF, for SSF is from 25 to 40. Then for 2.16 times SSF minus 60 over SSF for SSF greater than 40. This is now the viscosity. Properties, ito. Oh, yan. Or, okay, hindi na ako mababanggit lang from other reference. Basta ito lang gamitin natin muna. Specific gravity. So the specific gravity of a liquid and its applied gravity are related by the following equation. The specific gravity at 60 Fahrenheit is 141.5 over 131.5 plus API. Now the specific gravity is the value at 60 degrees Fahrenheit, since by definition API is always at 60 Fahrenheit. Thus, given the value of applied gravity of a petroleum product, we can easily calculate the specific gravity at 60 Fahrenheit using this equation. So from the sign of Boson element by first, the specific gravity of a petroleum oil at any temperature is approximately by SGT is equal to SG60 minus 0.00035 times T minus 60. T is in Fahrenheit. Okay. Next, flow condition. The handling system should be designed to provide a streamlined flow at all times when steady and predictable pressure conditions are essential. So, ibig sabihin, laminar siya. The Reynolds number of flow is a dimensionless parameter that depends on the 5 parameter liquid flow rate, liquid viscosity, and density. It is defined as follows. Reynolds number is equal to BD rho over mu is equal to BDB or nu and nu. Ito, kinematic viscosity sa baba. O para sa symbol. Okay. So, yan. R, Reynolds number, dimensionless. B, average velocity sa taas. D, inch diameter of pipe. Feet, rho, mass density of liquid, slug per cubic feet. Mu is equal to dynamic viscosity, slug per feet per second. B is the kinematic viscosity, feet squared per second. So regimes, flow regimes characterized by Reynolds number of flow are laminar flow. Reynolds number is less than or equal to 2,100. Critical flow is from 2,100 to 4,000. More than 2,100 to 4,000. And turbulent flow is more than 4,000. Yung Reynolds number. So yeah, kinematic viscosity. So ito ang rules. So pressure drop under streamlined flow condition is directly proportional to the quantity of oil flowing. So the effect of reduced flow rate after takeoff point as compared with flow rate through the full length of the pipeline when there is no takeoff should be taken into account to ensure that variation in pressure is within the specified pump output. So the Darcy equation may be used to calculate the pressure drop in the pipeline as follows. H is equal to F times L over D as B squared over 2G, where H is the frictional loss feet of liquid head. L, the pipeline. D, inch diameter, pipe diameter. B, average flow velocity feet per second. G, acceleration due to gravity in feet per second squared. In laminar flow or streamline, deflection factor F depends only on the Reynolds number. It is calculated from F is equal to 64 over RE, where F is the deflection factor for laminar flow and R is the Reynolds number for laminar flow, which is less than 2,100. Now, length of pipelines. Ilang ba sa yung length? Kasama yung mga fittings at elbow. So pressure drop is proportional to the length of pipeline. All fitting used in the system should be included in the determination of effective pipe length. Yan. So table 6 and 7 should be used to determine the equivalent length to be added to actual length of the pipeline for various types of fitting. The resulting figure is the total equivalent of the system. So ito yung installed fitting. Ayan yung elbow T. return bends. Kami ng return bends, valve. Sa tees, meron siyang strainer. Ang mga pipe mo. Straight sa pero regular electric division ko. Ano yan? Long radius, 45 degrees. Sa T, meron tayong line flow. Yung idiretso. Tapos sa branch flow, yung lamig ko na sa branch. Ayan. Kaya ang sizing mo ng flexion, kukunin mo is yung after. Kung isa, mag-separate siya. So after ng separation, ano yung type size doon yung gagamitin mo fitting dun sa ma-include. Table 7 is in meters. Now, for the velocity, meron naman tayong recommended. Oil pipes recommended flow velocities. Flow velocities in oil pipe should be kept within certain limits. So itong table 8. So huwag kayong lalampas dyan. Oil application, suction line for pump is in meters less than 0.5 feet per second, not less than 1.6. Suction pump lines for pumps at low pressure, so ito yan. Discharge line for booster pump, so 1.0 to 2.0. Discharge line for burner pump is less than 1.0. May example naman tayo. Branch line, so yung pinaka-last to, di ba, sa branching. Branch line, transfer oil from a ring main circuit to the oil-borne equipment. Where a residual oil fuel is to be used, there will be some cooling of the coil immediately adjacent to the pipe surfaces, and this will show us a small increase in viscosity. So to keep this variation to a minimum, and so prevent any difficulties in automation at the oil burner, care should be taken over the length and diameter of branch line. Masyadong mahaba. In general, the following empirical formula should be used when designing branch line for hot residual oils. So the length is 7L is less than square root of M in SI units, or length is less than square root of M imperial units or English units. So the L is the equivalent length of branch line in meter or feet. M is the minimum M oil consumption, liters per hour or gallons per hour. Now the diameter D must be less than 10.4 L in SI units. D is less than L over 8 in English units or imperial. Provisions should also be made to isolate and drain branch lines. So may drainage ka at may valvula ka. Ito yung mga dimension and buoyant force of empty storage tank. Yan. So gagawin natin, ano ito yung tank capacity in gallons, tank diameter, tank length, tank weight, wall thickness, and the net upward force, net buoyancy in pounds, submerged in water. So ito yung force alalim niya. Okay. Kailangan niya yun sa pag kinabit niya na yung tanke. Yung support niya. So dito sa tank capacity, so yan, meron mga pare-pares ang size pero iba-ibang dimension. So, pag na-compute mo yung gallons, example natin, bawa 11,000, so okay itong piliin mo itong dalawa. Ang thickness dapat parehas, magkaiba yung diameter, so isa lang ang parehas dyan. So ito, dito ka mag-interpolate. Kung 11,000 ka, so dito ka mag-interpolate. Isa lang, huwag ka mag-interpolate lahat. Okay? Dito pwede. Dito, sa diameter and length, huwag mo siyang interpolate parehas. Diba? E kukuha ka ng isang parehas na, 10 and 12 parehas, dito ka mag-interpolate. Importante dito, same thickness. Okay? Kung magkaiba yung thickness ng kataon, magkaiba yung thickness, wala dito, 13,000 ka, magkaiba yung thickness, 1/4 and 5/16, so kunin mong thickness yung mas makapal. Okay? So marami niya nag-interpolate. Ito, 22,000. Ito, nakuha niya is 22,000. Nag-interpolate siya dito, nag-interpolate pa dito. So, nag-interpolate pa dito. So, mali yun. O nagkumuha sila malaki, kasi itong dalawa, nag-interpolate sa both. So, hindi pwede. Hindi ka pwede mag-interpolate dito. Lalo na sa diameter. Kasi ang diameter sa volume is squared, di ba? Pi d squared times the length divided by 4. So, saan ka mag-interpolate? Linear interpolation sa tank length. So, next, appropriate approximate fuel consumption. Ito sa sabi kong table. May mga table dito, depende sa brand. So, meron sila dito, full load, 3.5, 3/4, 1/4. Yan. So, gamitin natin pa rin is, kung ano pinagamit sa inyo. Yun. So, meron pang rule of thumb dito. As a rule of thumb, for sizing generator fuel oil system, each 100 kilowatt of generator capacity will consume about 7 gallons per hour. Any oil that is pumped to engine but is not returned to the daytime would add to the generator capacity based requirement. So, approximation lang ito. Ito yung based sa catalog. Ito naman sa Morse, pagkuha mo ng fuel consumption, sa Morse naman ito. Diba? Kung ilang percent yung ano mo, percentage load, makuha mo yung fuel consumption dyan. Ang capacity, 40, andito yung ano niya, generator output per kilowatt hour liter. Kilowatt hour per liter oil. So, plant capacity to ang plant sa planta. Dito tayo. Ang isang diesel engine, ito yung, kung iba, 100% siya. So, dito ako kukuha. Alin ang maximum dyan? Ang unit mo is fuel consumption in kilogram per brake horsepower hour. Or, dito sa kabila, fuel consumption in kilogram per kilowatt hour. So, magiging siya, ang consumption mo is denominator. So, ito yung maximum mo sa baba, ito yung minimum consumption mo sa taas. Okay? Huwag ka nang baliktarin. Sa example ko yun. Ang ginawa ng iba, binaliktad pa. So, pinaliak ko. Kasi baliktad, ito na nga. Dito yung maximum consumption mo sa baba. Tapos kasi pina-average ko eh. Tapos ito naman sa taas is yung minimum. Kasi pag na-reciprocal mo yan, mababa to, ito na taas. Di ba? Ang luwas niya is kilogram. So example number 1. G-Side, a fuel storage tank of and fuel oil piping system for 500 kilowatt generator. Use diesel number 2 fuel oil. Pipes and fittings, ito, yung pipe length is 40 meters supply, 16 meters return. Gate valves is 2 pieces supply, 1 piece return. Spring check valve is 1 piece. Natakpan lang. Then, strainer is 1 piece. Kasi sa pump to. Then, elbow, assured. Kung pila nakita mo elbow dyan. T, assured. Kaya din kung nakita mo dyan, huwag na lang magdagdag. Okay? Yung iba nagdagdag siya, lumiko pa kaya niyan sa ano. So, hindi. Ito lang tayo. Assured. So, pumping rate is 2 times the firing rate. Yan. Ayan. Determine the size of the storage tank. Dimension. Kailangan. The volume. In meters. So, pipe size, pwede siyang in inches kasi ang mga pipe commonly in inches. C, the total pressure drop, both supply and return. Kaya total, 10 kilopascal. So, ito yung oil mo, punta dito daan sa pump, in, out. Tapos, gagamit ng boiler, so babalik siya. Sabihin, ang pumping rate mo is 2 times the firing rate. Ang firing rate mo yung pumapasok dito na gallons per hour dyan dito. Diba? So, times 2 niyan, ito yon. Okay? So, babalik dito, same ang size ng firing rate. Okay? Kung minsan, mag-iniba mo na yon, so mag-iibang value nun. Doon na nagkakamali. Diba? Tama yan. Given, assured in the following pipe length, yeah, gate valves, trainer, elbows, T. Required size of the storage tank, pipe size, and total pressure drop. Solution, generator Its size is 500 kilowatt. So each 100 kilowatt of generator capacity will consume about 7 gallons per hour. So the full load fuel consumption is 500 times 7 gallons per hour per kilowatt, 100 kilowatt. Okay, tama. Is 35 gallons per hour. Fuel oil is number 2, the diesel fuel oil. So A, sizing the storage tank. So use 3 weeks supply of oil at maximum rate of consumption. So for the purpose of charging storage tank, it may be considered that a gallon of fuel oil will generate 10 kilowatt hours. Yan. Ito sa ano? Ito sa sizing ng tank. A gallon of fuel oil will generate 10 kilowatt hours. So capacity ito sa consumption, ito sa tanke. Capacity of the storage tank is 1 gallon per 10 kilowatt hour times 100 kilowatt times 3 weeks times 7 days per week times 24 hours per day. So capacity of the storage tank is 25,200 gallons. Okay. So kung malaki, wala sa doon sa ano sa table, hatiin niyo yung tanke. 50,000, wala naman dito sa table. So hatiin niyo sa magiging 225. Okay. So ilalagay niyo yung quantity. Ilang units? 2 units of ganito. 2 by 20 to 200. Okay. From dimension in buoyant force of empty tanks, dito, meron 20,000 and 30,000. Parehas ang diameter, so solve for X. So dito sa thickness, pipili ka, siyempre yung malaki. So X is equal to 31 plus 46.25 minus 31 times 20,200 minus 20,000 over 30,000 minus 20,000 is equal to 38.93 feet or use 39 feet. Now, diameter based on sa pinili mo is 10 feet 6 inches or 126 inches or 3.2 meters. And the length is 39 feet is 468 inches or 11.89 meters. Then the thickness is 38 inch or 9.5 mm. Check for volume. So yan sinelect mo. So check for volume. Baka kulang. Kasi meron tayong ullage. So volume is pi over 4d squared L or pi over 4 times 126 squared times 468 is equal to 5,835,483 cubic inches. So divide mo ng 231 para maging gallon is 25,261 gallon. This is less than 21,200 times 1.05. Check nyo na lang yan kung tama, kung less na siya. Kasi yung 5% is yung ullage mo. Okay. Kasi table to. Buo. So ullage, increase tank length by the ullage. So L is equal to 468 times 20,200 over 25,261 times 1.05 is equal to 490 inches. So now, ito na yung final dimension mo. Diameter, 3.2 meters. Length is 490 inches or 12.45 meters. Nagbago, di ba? Para mapasok ang ullage mo. The thickness, 9.5 mm. So ullage is 5%. Pipe size. Ito na, each 100 kilowatt of generating capacity will consume about 7 gallons. So yun nga, 35 gallons per hour. Ito yung piling rate. Diba? Consume. So table 4, so 30, C, number 2, diesel fuel oil, and viscosity was 50.6 SSU. So synthesis stock is equal to 0.226 times SSU minus 195 over SSU is equal to 0.226 times 50.6 minus 195 over 50.6 is 7.582 synthesis stock. And table 3 is specific gravity of diesel fuel oil number 2 at 60 Fahrenheit is 0.86. At 30C, which is equal to 86 Fahrenheit, so specific gravity is equal to SG60 minus 0.00035 times 10 minus 60 is 0.86 minus 0.00035 times 86 minus 60 is 0.8509. Now, the kinematic viscosity, synthesis stock is absolute viscosity at synthetic force divided by specific gravity, or 7.582 is equal to absolute viscosity at synthetic force divided by 0.8509. So absolute viscosity CP is equal to 6.452 cp. So, yeah. Select pipe size by trial and error method by limiting the Reynolds number less than 2,100 and velocity 0.5 meters per second. Yan. First trial mo is 1 lap. Yun ang pinakamaliit. So, schedule 40. So, out diameter is 0.84 inch. So, sa more, sa likod, meron doon schedule ng pipe schedule. Makuha mo yung outside at inside. So, that is, so 1 inch, ang outside na is 0.84 or 21.36 mm is 0.02136 meter. Ang ID is 0.622 inch is 15.7988 mm or 0.0157988 meters. Kaya huwag nyo gawin 0.02. Kaya i-round off nyo 0.02. Pares na yan 0.02. Diba? So, pabain nyo. So, flow rate is pumping rate is 2 times 35 gallons per hour or 70. Kasi 2 times the piling rate. So, minsan, bibigay ko 2.53. So, ibig sabihin, hindi equal yung return. Diba? Ito kasi nagkataon times 2. So, kaya, pumping rate, yung return mo is pumping rate minus piling rate, magiging 35 din. Okay? Pero pag nag-times 3, so magiging 35. So, ano, return mo is 70. Kasi times 3 nga, yung pumping rate. Okay? So, anyan. Diyan na kayo malilito. So, Q is equal to 70 gallons times 231 cubic inch per gallons times 1 foot over 12 inches times 1 over 1 meter over 3.28 feet cube times 1 hour over 3600 seconds is 0.0000076 cubic meter per second. Ang round off nyo. Pag lumayo sa sagot, wala na. So, dito, ito yung mga factor na to. Simple lang. Kasi 7 gallons per hour, hanap ka ng conversion ng cubic meter per second, di mo tuong, hanap ka online. Tapos madali may multiply dyan, okay lang yun. Pero kung wala ka, so ito mga tandaan, conversion factor. Then velocity is 4Q over pi d squared, Q over area, or 4 times 0.000076 over pi over 0.0157988 squared is 0.3754 meter per second. Less than 0.5 meters per second. So, valid. Pag naglampasan ng 0.51 o 0.6, change ka ng 1 inch. 1/2, sunod 3/4. Sunod 1 inch. Okay? Now, the Reynolds number, check mo rin. Pagbaok ito, is BD over B. B, kinematic viscosity. Kinematic. 7.582 centistoke is 7.582 times 10 negative 6 meters squared per second. So the Reynolds number is 0.3754 times 0.0157988 over 7.582 times 10 negative 6 is 782. It's less than 2,100. Okay. So pag nag-more than siya, so invalid naman yung 1/2 mo. Okay. Therefore, use pipe size of 1/2 inch, schedule 40. Huwag na kayo magpalit ng schedule 80. Kaya naman ng ano yan, ng temperature. So yan. So ito nga. So supply mo is 70. Ito is yung balancing balance to. So 0 muna, close yan, close. So gagamit siya dito ng 35. So babalik siya ng 70 minus 35 is 35. So ito, nakita niyo itong 35 gallons per hour, hindi ito timing rate. Ito yung return. Return. Kung kopya kayo ng kopya, dito ngayon nakalagay yung 35, gawin nyo na. Okay? So, ang return to rate mo is 35 gallons per hour or pumping rate minus the firing rate. Okay, so Q is equal to, convert 0.000368 cubic meter per second. So, the velocity is, B is 4Q over pi d squared or 4 times 0.000368 over pi over 0.0157988 squared is 0.1877 meter per second, less than 0.5. Yan. Also, dito, ginamit natin is 1 pa rin. Okay? Kasi yan ang minimum. Pasok siya, hindi ka na pwede magpaliit. So, minsan, pwede kang maging iba. Ito, 3 ports, ito 1/2 yung return mo. Kasi, mama, mas malaki yung ano, di ba? Yung supply, pumping rate. Sa return mo, maliit na yung flow, pwede ka magbaliit yan ang pipe size. Basta tama yung procedure mo. Okay? Yan. Paano nyo gagawin yun? So, huwag nyo na munang i-try. Ito na lang sundan nyo. Same size na lang kayo. Kasi nung pinaiba ko yung size, maraming nalaglag. Wala. So, Reynolds number is 391. Less than 2,100. Now, supply line equivalent length. Hanapin nyo sa table na lang to. So, pipe is 40 meters given. Quantity is 1. So, 40. Gate valves is 0.2, dalawa, 0.4. Swing check, 2.4 times 1 is 2.4. So, total is 47.8. Sa return, so ito rin mga value niya. So, that is 64.2 meters. So, i-add mo yan. Hindi mo pala pwede i-add to length, equivalent length. Kundi, ito muna. Pressure drop for supply line, H is equal to FL over D, B is equal over 2G. For laminar flow, F is equal to 64 over RE is equal to 64 over 782 is 0.082. So velocity is 0.3754 meter per second. L is equal to 7.8. D is equal to 0.0157988. Substitute values. H is equal to 0.082 times 47.8 over 0.0157988 times 0.3754 squared over 2 over 9.81 is 1.782. And delta PS is equal to specific gravity times density of water times D times H. Okay, bakit water? Kasi pag multiply mo sa specific gravity ng oil, so this is now density of oil. So delta PS is equal to 0.8509 times 1,000 kilogram per cubic meter times 9.81 meter per second squared times 1.781 meter. So delta PS is equal to 14.875 Pascal or 14.9 kilopascal. Then sa return line, H is equal to FL over DB is equal over 2D. So for laminar flow, F is equal to 64 over RE is equal to 64 over 391 or 0.164. Yan. Laminar flow. So bababa yung Reynolds mo, pero yung friction mo tumaas. So talaga mas dapat talaga paliitin mo yung pipe. Kaso na nagkataon, 1 na pag minimum. So the length is 64.2 meter. D is equal to 0.0157988 meter. So H is equal to 0.164 times 64.2 over 0.0157988 times 0.1877 squared over 2 over 9.81 is 1.197 meters. So delta PR is equal to SGT rho. So WDS then is equal to 0.8509 times 1,000 times 9.81 times 1.197. H na dyan. So delta PR is equal to 9,992 Pascal or 10 kilopascal. So total pressure drop, delta P is 14.9 plus 10 or 24.9 kilopascal. Ito na yung pressure drop mo dito. With the pressure drop and the flow rate, makukuha mo yung size ng pump mo. Research ka na ng tangke, saka pipe. Sample number 2. A diesel plant will have 1 775 kilowatt and 2 400 kilowatt units. So delivery of the fuel is to be arranged on a monthly basis. The vendor expecting to deliver by tank car. So expected plant capacity factor is 31%. So the tankage and the tank transfer system will be size. Ano yung size ng tanke? So generator efficiency 94%. Density of oil 0.9 kilogram per liter. Use figure 6-15 from Power Plant Engineering by Morse. So ito yun. So given diesel plant units 1 775 kilowatt and 2 400 kilowatt. Fuel delivery monthly basis. Expected plant capacity output factor is 35%. Generator 94%. Diesel of fuel oil is 0.9 kilogram per liter. Required tank size and transfer pump size. Ano yung flow? Solution, sizing tank. Kasi wala ka namang piping, so flow lang. So the plant capacity is 775 plus 2 plus 400 is 1.75 kilowatt. Average output of 35% load factor is 0.35 plus 1.75 na. So 550 kilowatt. From feedback 15, 6 plus 15. So at greatest fuel consumption at 35% capacity factor, so yun, at 35%, ang greatest mo, 6 plus 15, 35, greatest mo sa baba, kasi ang liter mo sa ilalim, 35, 1.72, yeah. And lowest is 35% at 35%, 2.64. Yan. Diba? 35 yan. So, tantayin yung tama. Baka dito ka 35, binasa mo, nasa taas. Okay, meron ganyan. So, yun. So, average fuel consumption at 35% capacity factor is 1.72 plus 2.64 is 2.18 kilowatt per liter. So, the required storage is 550 over 2.18. Diba? 550 kilowatt divided by 2.18 kilowatt per liter oil. So, magiging liter. Times 24 hours a day. Times 30 days is 181,650 liters. Okay. Yan. So, kasi magiging liters per hour. Times 24 hours a day. Times 30 per day. Times 30 days. Yan. Therefore, use 5 times of 36,330 capacity. Saan galing to? Dito siya. Sa pinakaunang topic natin, 36,300. Nakikita mo yung yan, capacities. So, dito siya. Tankers yun. Tankers, di ba? Tankers. Capacities na ng tanke. Delivery dito. Ayan. Tank cars, itong average mo, 30,300 to 45,400 liters. Most them. Okay? So, meron siya dito. In liters kasi yon. Kung galos, may ka dito. In liters to, available. So, yan. So, i-divide mo yon. Anong average nito? I-divide mo dun sa nakuha mo. Tapos, gawin mong whole number. I-divide mo ulit. Yun ang capacity ng tanke mo at quantity. Layo. So, yan. Ayan, 36,330 capacity time at 5. Diba? Yung 181,650, divide mo nung average mo kanina. So, makuha mo, approximate whole number mo. Whole number mo yung mataas. 7. So, 5. Tapos mo 4.8, so 5 mo. Kung 3.8, huwag mong gawing 5. Ginaya mo na siya sa kabila. This is equal to 36,300 times 0.9 or 32,697 kilogram or 72,100 pounds or 36 tons tankers. Okay? Dalawa ang sagot mo dito. Isang kiliters, isa tank, in pound, in tons. Yan. Now, sizing transfer system. Ilang liters per sec per minute. Okay? At full load rated, fuel consumption is figure 6 na 15 above. Average mo na lang ito. Ayan. This average. So this is BHP is equal to 1575 kilowatt over 0.746 kilowatt per brake horsepower is 0.94 is equal to 2246 brake horsepower. So maximum rate of fuel usage is 2246 times 0.80 is 404.3 kilograms per hour. So the flow rate is 404.3 kilograms per hour divided by 0.9 kilogram per liter is 449 liters per hour or 7.5 liters per minute. So the transfer pump and piping should have at least 7.5 liters per minute. Yan. Okay. So dito, kukunin nyo yung maximum minimum para makita yung average nyo. So dito, hindi kayo pwede, yung direkta kayo ng average dito, mahirap. Hindi nyo matansya. So dito, maliit lang kasi yan. So pwede yung average. Ito masyadong mahaba. Okay. So huwag nyo yung average, direkta. Assume, kailangan nyo mag ng maximum and minimum para maintindihan nyo alin yung maximum doon, ang greatest at lowest. Okay? So, this is the end of this topic, fuel oil system.